Ladies and gentlemen, boys and girls, welcome to the Programming Theory Medley. Before we begin, please remember to give this video a like, subscribe, and ring that bell. And also tell your friends all about these wonderful videos. My mission is so I can get actually some money from this YouTube channel, so I can retire, have a boat, travel to Russia, have some great times, you know, etc. Anyway, let's do it. So let's start off with a question which I'm going to ask you, which is list each data type. Yo, this pen is thick. Let me just change the thickness. There you go. And give an example of each one. Pause the video, give it a go. Okay, this is really easy. Data types, so I'm just going to label this section data types. In fact, let's do this. And let's label them. So we've got a real, we've got an integer, real or float, I don't care which one you go with, string, char, boolean. Now if I had to give an example of each one, I'm going to make it up. So I'm going to do price of an item, i.e. 4.99. If I'm going to do integer, I'm going to do age in whole years, i.e. 10. String, name, i.e. in speech marks, Joe. Char, initial, i.e. J with single speech marks. Boolean, are they married? False, they're having an affair. I have no idea what I'm talking about, but there you go. So you got real, integer, string, char, boolean with a nice example of each one. They are our data types in programming. I'm going to give you another question. List different data structures and give examples. Pause the video, give it a go. So data structures are basically concepts which store data whilst our program is running. So what can store our data? Well, we can store our data into a variable, i.e. score. We can store data in a constant, so a value which doesn't change, i.e. what doesn't change? Pi, if we're using pi in our app. We can store data in a 1D or 2D array. So I'm just going to do a 1D array, i.e. player names, and then like Joe, Mikkel. There you go. So those are different data structures. These are different data types. How else? Okay, so here's another question. So I'm just going to zoom out. Give another way we can store data in our app, but permanently. This is a tough question. See if you can give it a go yourself first. Pause the video. Okay, so we can store data in variables, constants, arrays, but the problem is every time we load up the program, it will erase data which we've generated. However, we could also store data in a text file. Example, if I'm playing a game like Hades. Yes, Kamani, Hades. And I want to save my life, and I want to save what level I'm at, so like the stage. If I was just saving it in a variable or storing the information in a variable, The problem is, if I quit the game and turn it back on again, it's volatile. That basically means my lives will start back at, I think it's 100. I'll start back at level 1. But instead, what I'm going to do is I'm going to save all my data to a text file, because a text file is non-volatile. What happens is it saves all my Python data, like my scores, my lives, into a text file which goes into my SSD, which is obviously, as we know, non-volatile. Non-volatile, that receives SSD, so we can reuse the data over and over again. What I didn't mention about text files is that also you can load up the data again. So let's imagine that we've got in our text file a whole load of top scorers in our game. If we didn't have a text file, we would need to manually put each top scorer back into our code. Text files, we can just reload it in, we can put it into an array, and it's done for us. So we can load up data as well as save data. Whoop. Okay, so let's do another question. Give an example of selection and iteration. Pause the video, give it a go. Okay, so selection is like an if statement. An iteration would be a loop. And we can go into the different types of loops. Ooh, that's a good idea. Let's do that. I'm going to do a question. Explain the differences between the different loops. Pause the video, give it a go. Okay, so I'm going to do a for loop, which is a count controlled loop, which runs set amount of times. You've then got a repeat loop, which we know is a post condition loop, which will run at least once. We then have, oh, I'm going to add checks condition at the end. We then have a while loop, which is a precondition loop, which may never run. Checks condition at beginning. My handwriting is nearly as bad as Max's. No offense, Max. But at least I'm not talking about Pearl Harbor. Okay, so we looked at data types, data structures, different ways we can save data permanently, which would be like a text file, non-volatile, we store to SSD, so we keep our data, examples of selection, examples of what is meant by iteration, different types of loops. So where do we go next? Easy. Give an example of counting and totaling. Nice and easy. Easy peasy. So pause the video, give it a go. Okay, so counting is simply where you have like a variable equals, I'm going to do pseudocode here. Let's make this pen a little bit thicker, just a tiny bit thicker. Let's do it at 2. Why did that work? 2 please, thank you. So count equals count plus like a set value, like 1 or 2 or 3 or 4, whatever it is. That would be counting. Totaling would be like a total equals total, so using the same variable again, plus another variable like sum or score. So it needs to be the same variable again, plus a different variable. so the value changes each time. So far we've done loops, counting and totaling recently. What else? Okay, so why don't we do this? We have right here arithmetic, logical, and Boolean operators. Which of these are also library subroutines? Pause the video, give it a go. Okay, so you should have said mod and div. So when we do programming, you've used most of these before. Not really this one, but you've used these a heck of a lot. You also use these a heck of a lot. This is the same as this in pseudocode, not equals to. And we've also used and or not, like if password is this and this. So you've used Boolean, you've used logical, use arithmetic, mod and div. These are our library subroutines. So my next question to you is going to be, what is the purpose of mod and div? Pause the video, give it a go yourself first. Okay, so I'm going to do mod. That returns the remainder from a division. I always like to do an example in my exam answers, and you guys should get into the habit of doing that as well. i.e. 11 mod 3, so how many 3's going to 11? Go 3, remainder 2. R2, so it's going to be the 2. 2 is the answer. Whilst div returns the value without a remainder, i.e. 11 div 3 equals 3. No remainder. Okie dokie. So I mentioned the word subroutine. I also mentioned the word library subroutine. So let's start off with subroutines. What is a subroutine? That's an interesting question. Pause the video, give it a go. So a nice answer would be a subroutine is another name for a function / procedure which is code in modules that perform a specific task. My advice is, if you've not watched the tutorial, video I've done recently on functions and procedures, go and do that before we proceed on the rest of this section. Okay, so basically a subroutine is a functional procedure. You could also say what is meant by modular programming or using modules in programming is a functional procedure. Now, let's spice things up. What is the difference between functions and procedures? Pause the video. Okay, so this is actually a little bit tricky. So this is what we know. Subroutines do not, procedures do not return a value. We know that functions return a value. A little bit of new knowledge. Well, not really new knowledge, it's about gluing things together. If I was to, and I mentioned this in my other video to be fair, if I was to do a function called like def score, and we're going to make a argument or a parameter called x, and we're going to do x equals x plus 1, and we're then going to return x. Let's now call score. I'm going to put in the main code x equals 2. We obviously need something to store the result of the function as a return value. So let's make final score as a variable. Final score equals score x. So if we do print final score, the answer will be, if I run our code, 3, because it'll pass 2 as a argument or parameter into here. So this will be 2. 2 plus 1 is 3. It'll return x, the value, into here. So, but what's actually happening here? Well, we're assigning score into final score. We're passing that score into there. It's like me doing this. Score equals 9. We're assigning 9 into score. But instead, in this case, we're assigning the function score into final score, the result score. So it runs all of this and puts into final score. If we print final score, it'll show us the updated value. So the terminology is assigning. So if I go back to what's the difference between function and procedure, a function returns a value and assigns it into a variable. Okay, so we looked at what's the difference between functions and procedures, what's a subroutine, or what's meant by modules. Let's do another function question or procedure question. Okay, so I'm going to do this, def score, and I'm going to do x again. My question to you is this, and let's do return x, and let me, what is this called? So I'm going to put A. Also, what do we call a variable inside the bracket? B. Also, what is happening here? C. And D, how do we call the function based on this? Pause the video, give it a go. Okay, so let's answer this bit by bit. A, this is called a function header. And actually the function header is all of this whole line. It's like the start of our function. What do we call B, the x inside of here? Well, we call that a parameter or an argument. What do we call C? Well, we call this the return value. So what's being returned. And how do we call the function? Well, to call the function, we need to put a function name, which is score. Open bracket, close bracket, and in this case, we need to put an x. Also, we need to assign a variable, so we'll call it y equals score x. Okay. So pause the video, give it a go, list the different library subroutines. Okay. So what we should have had is mod, div, round, and random. Each one of these you should be comfortable in identifying. So my next question to you is going to be, what is the purpose? I'm going to put /benefit of let me change subroutines to library subroutines. Library subroutines, such as random. What's the benefit or purpose? Okay, so I'm hoping you're going to understand this. It is code, a variable to use straight away because it's already done for us. Therefore, it's going to be reliable because it's been done for us already. So it's not, let's say, Kamani doing it. No offense, Kamani. You know, you're a good kid, but you might make a boo-boo. It's going to be reliable. And it's going to be fast to use because we don't have to program it. No real programming the code behind it. It's done for us. So it's code which is available for us to use straight away, which is basically me repeating this by saying it's fast. That's why we use library subroutines. Okay, let's move it over. So let's have a quick recap. We did data types, we did data structures, we did about text files, we have a selection and iteration, we looked at the different loops and the differences between them, we looked at counting versus totaling, we looked at arithmetic, logical and Boolean operators, and we looked at which ones out of those were library subroutines which our exam board needed to know about, which is modern div, although theoretically you can argue about all library subroutines. We then looked at the purpose of modern div. We then looked at what is meant by subroutine. We then looked at what's the difference between functions and procedures. We then looked at labeling a function and calling it. We then looked at listing the different library subroutines. We then looked at the purpose and benefit of library subroutines. So your next challenge, let's take you right back to over here, is I want you to, in fact, let's just zoom right in, list the program development lifecycle, the different steps, phases of it. Pause the video, give it a go yourself first. Okay, so I'm hoping you've gone for analysis, design, coding, don't know why I did that little thing, and testing. So my next question to you is this. Give me 2 steps of analysis. 2 things you would do during the analysis stage. Pause the video, give it a go yourself. So I'm hoping you've gone with abstraction and decomposition. So I'm going to ask you to elaborate on what is meant by abstraction and what is meant by decomposition. Pause the video, give it a go. So abstraction is the process of eliminating, I would say, irrelevant details. You can also say complex details. Whilst decomposition is breaking down a problem into smaller parts. I'm going to throw another one in there for analysis. So I'm going to make it now 3. And that is what we call problem identification / user requirements. So hear me out, this is quite easy. This would be basically someone saying to you a wish list of what they want made. So the problem identification is, I've got a problem which I need you to make for me, like I need an app which is to be made, that is my problem. I want the app to have, so it's like a, I want made, and this is going to be like your wish list. I want it to have a list of all the restaurants. I want it, a customer to be able to order. I want it, customer to be able to see their tracking. So that would be analysis in itself. So continuing on in the same vein, give me, let's go with 4 activities that can be done at design stage. Pause the video, give yourself first. Okay, so you can talk about pseudocode, which is very easy. We can talk about structure charts or structure diagrams or module charts. We can talk about flowcharts. And we could also mention, again, further decomposition, breaking down the problem into even more parts. So those are 4 activities that could be done at design stage. Coding is dead easy. I'm not going to go into that. It's just coding. So let's then go into, before we do that, I'm going to ask you a question about structure charts. Explain the purpose of structure charts. Why do we use them? Pause the video, give it a go. Okay, so the purpose of a structure chart is to give you an overview or high-level view of your code and all the modules that you have, or subroutines. So remember, when you do things like this, where like be your main code, and then you've done this, and you've done this, and then we've had like user input, that'll be a subroutine. Then we'll have output, like what's going to be displayed on the screen, that'll be another subroutine, user input. They'll be able to do it by clicking on images, text. So all of these are subroutines, part of the overall code. This is a structure chart, it gives us an overview, a high level view. So let's move on to testing. Okay. So let's start off with list the different test data type. Yeah, let's rephrase that question. I don't like that. List the different types of test data. So whenever we talk about testing and test data, there are different categories, different types. Pause the video, give it a go yourself first. Okay, so we can mention normal, abnormal, extreme, and boundary. So I'm going to give you another challenge. If we wanted to test a system which should allow you to type in a test score between 0, actually let's do 1% to 100%. Give an example of test data we could use for each one, for each type. So for normal, so pause the video, give it a go. Okay, for normal, I'm going to do 50%. For abnormal, I'm going to do 50 as a word. For extreme, I'm going to do 1%, and for boundary, I'm going to do my 1%, 100%, and my 0%, and my 101%. Let's give another question. How else can we test? So how else can we test our program, our app, our program code? So think about other exam questions you've done in the past where we've actually had to test the code. Pause the video, give it a go yourself. Well, oh, here comes my food. Pause. Okay, I'm back now. I had a nice little steak from the kitchen, very good. It was really good actually. They put a bit of butter on it, they gave me a nice steak sauce. Anyway, the answer to this would be what we call dry run testing, or a trace table, which you may have to do in your mock, where you have that table, you have a flowchart, or you have code, and you've got to fill out the table based on what you see in the flowchart. the example videos on this playlist as well. Okay, let's finish this off with 2 more questions. List different validation rules that you can apply and list different verification rules that could be applied. Pause the video, give it a go yourself first. Okay, so we've got length check, range check, format check. You've also got data type check, and you've got presence check. With verification, you've got double entry, like double entry of a password. You could also have somebody proofreading what you've done. That's also verification. Proofreading means someone else reading what you've done, going over it, checking it out.